Okay. Good afternoon. Thank you for making the time to be here. Just as a quick background, so human factors, I don't know if you've heard of it, the big premise behind human factors is that it's very, very typical for engineers to blame the user. So that's, human factors are supposed to be against that, against blaming the user. It's not about user error, it's about use error. So how can we make the design and improve it so that we don't put our users into difficult spots? I guess my background, I'm in medical devices, I'm in engineering. I didn't anticipate going into this field, but I really, I didn't even know about human factors as a path, but I think it kind of helped reveal for me that there are ways that God, I guess that's the premise of it in God's design. That's what I wanted to explore with this talk versus man's design. And so there were a couple case studies I was going to go through to illustrate, the main premise of it is not to vilify the companies where these mistakes happened, but to kind of show a perspective of where it's very easy for design or teams to kind of overlook the less known, maybe you forgot certain users that are involved, and then it actually really goes against what the original intent or design of your product was supposed to do, and it might harm someone. So that I had a couple case examples for that. I don't know how many of you guys have heard of the field of human factors before. Okay. I think. Okay. Yeah. Let me think. So I guess one of the first slides I had on there was there's a list of things that you want to associate with your product. Like in med devices, you might be a list of 5 things, like safe, effective, able to functionally do its job, maintainable. There's something else that I listed on there. And on that slide, I guess my question for you guys would be like, maybe just internalize that. Which one do you think is the most important thing for a medical device? I don't know if maybe you've used them being from contact lenses to, I don't know, glucose meters or other things in your life. You can feel free to shout out something that you like. Right? Yeah. No, that sounds great. You don't want to be hurting people when you're doing it. But I was going to just show also with that, there's a slide that kind of shows, it's based on the Stroop test. I'll let you guys try it in a bit, but it kind of shows, I think as humans, we have a challenge in trying to focus on multiple targets. Like usually, even for the compass, you only have one north or one direction. And so the challenge when you're focusing on safe or focusing on effective, it's really hard to remember the other aspects as well. And I think that's where we can be limited in human design. Okay, perfect. Thank you. Okay, guys. Yeah, you're welcome to visit for the other talk too, but this one is, I think, what you guys signed up for to come for. So just as a quick overview, I'll give you a quick background about where maintenance is involved for med device development. And 2 case examples, one about reprocessing, one about where batteries are used, and some lessons learned and some reflections from that. That image there is just a cue for me to remember. There's something really key for devices, how we have to remember how it can communicate system status and make our users aware what's going on. Because I think if you've probably experienced with a computer, you have either the swirling thing or the status icon or something. It's like you want to know blue screen and nothing happening is not good, right? So this is what I was kind of referring to, and I think you guys generally chose one. This was a test that I just was referring to, and I don't know, I'll give you a moment to give that a try. For anyone who wants to yell out an answer, that's fine too. Yeah, I think this is to illustrate that when we have multiple priorities, and it can be hard for us to focus on what the actual answer is, especially if there's distractors like this. I think that's kind of similar in parallel to when you have multiple parameters you're trying to reach. So this is taken from one of the standards in the field, and it's talking about the realm of use. For use, there's normal use, and then there's abnormal use. And I think automatically in device design, you kind of like say, well, those are the cases we cut out, abnormal, we can't account for those. But you do want to, under normal use, you want to capture where can things go awry and cause use error with the product. And of course, you're happy when they use it correctly. This is just don't be bothered by the flow chart, but this is a very characteristic, like FDA put out this guidance as the typical way for how you develop a medical device product and the cycle. I think the key part I wanted to highlight is the inputs require that you need to understand your users and their needs. And so that's the real start to the cascade for this whole process. And so just a quick background about maintenance. I think it's a pretty thought-provoking statement when I first heard it, when it's plumbers run the world. And it kind of takes you back, really? But I think there's an element of truth. I think it's very easy for probably even here in the Silicon Valley to see like, bright, shiny technology and think that that can fit in and solve all the issues. But then at the same time, like the picture illustrates, there might be some hidden underside that with the trade-off that you're taking on this technology and you could be trading for that, that might not be seen at first. So maintenance has some very basic definitions, including keeping, maintaining, or preserving medically to keep a patient stable in a stable condition. Latin is from to hold in the hand. There are many activities involved with maintenance, forms of it, cleaning it, or restoring, or changing batteries, or they're just several steps, possibilities of things that might need to happen in order to guarantee the safe and effective continuation of use of the product. I'm just showing this as a representation of, there's a very characteristic when people are involved in maintaining or calibrating equipment, they're all kind of a little stooped and kind of hunched over in awkward positions. I think that's just a tiny little window on, I don't think they were the primary users considered for this activity, because of course you want to make sure that it's properly used at the first case for the primary users, but there are also users as well. This example is a case study, again, not to vilify, but just to take what we can learn from what has happened. So actually, if you're able to reprocess or to process or clean devices, that's actually a really beautiful thing in terms of you're able to not use just like disposable, very cheap plastics. You're able to use more expensive materials. You're able to also potentially bring down patient costs for each use. So there are some actual benefits to actually having it reprocessed as a design decision for a product. But also, there's the ugly side where, in this case, so let's talk about the benefits of this product. This is a type of endoscope, a duodenoscope, which actually has a beautiful thing. You don't have to cut open the patient in order to be able to see parts of their small intestine and go in and take samples and things. So it kind of goes in and they're able to do things like take samples and view it. But at the same time, you'll see also there are many nooks and crannies, and there are a lot of steps involved with small brushes and other things that have to, that's the other trade-off. It's very flexible, so you're limited to materials that probably can't undergo high temperature steam. And so that's the trade-off where it has to go through this process called high-level disinfection. And actually, at a hospital, I believe in LA, they had, where it was a unique case where they were able to trace it back to the original patient where this very rare multi-drug resistant bacteria had spread. It was rare, and they were able to sequence and isolate it back to the original patient because it was such a rare multi-drug resistant thing. But there were several patients that ended up dying, and it was just something that actually put FDA in a position where they were even sued by people because they had approved for this device that it was safe and effective. But this is also to illustrate that there were several considerations where for users it's hard to tell whether something, can you tell it's clean? Can you tell you've done everything what you're supposed to do? The steps shown on the right are some elaborate steps for another product they developed to be able to culture and see like, okay, is there really bad bacteria left on your device? And it's just to kind of illustrate it. It's not easy for our users to tell that they've done their job completely. This second example involves batteries. And so I don't know if you've heard of the left ventricular assist device, LVADs. They actually do pretty amazing things. These patients, they have serious cardiac issues. And so this patient obviously has gained and maintained a level of quality of life despite having issues with, his heart condition. But also, on the other side, there have been also many patients. So in the process of using this device, it must require a battery replacement. And these patients, they're untethered. And so there's this thing about in the process of changing their batteries, they actually lost consciousness, and some died. And so, and also to complicate things further, there were other manufacturing issues with the batteries and other complicating things with the manufacturing that made it even more challenging for the users, right? Just to illustrate, so part of the use of the device, so when they go to sleep, they probably can get off the batteries and they plug into a wall, so this is like a wall-based unit. I have not personally worked with these devices extensively, but for me it was eye-opening to see all the connects and inner special connections. There's even a connector that's keyed on the where it fits in only a certain way. And so I'm sure there's a very important design reason why it must go in that configuration in that way. But at the same time, I don't think this necessarily makes it easy for our users or users of this device. At the same time, in order to be untethered from the wall, they have to be able to change the batteries, which have to be recharged and replaced every 3 hours. And so that was kind of eye-opening. But I was looking at those those lights, and I was like, wow, that's really hard. I don't know if I would understand it. I'm guessing the patients have to go through and understand what all those lights and icons mean. But it really did make me empathize a bit with, like, especially if you're just the effort of your day and having to see that, understand what has to happen. Also, you have to fit the battery in a specific configuration. The instructions you might not be able to see, they're tiny, but that was what was in the user manual for the patients to be able to figure out what they're supposed to do with batteries changing. So I think some takeaways that from this side, I think the example of the reprocessing, I think there's some considerations in these maintenance tasks. First, I think question is it easy for our users to tell it's clean? That's something that, the design probably could expand or process. For the battery example, is there a better way to potentially make it clear that what the system status is for the users? Is there also an easier way to change the batteries and make it like between the wall plug and the battery, make it a little bit less effort? So especially patients are already having this challenge. I think going back to the inputs part when I was talking about the design process, kind of understanding, I think it's pretty key in med device designs to understand who are your users again, and reiterating and going back through that and seeing that you really do understand who all your users are and what will they each see and touch, and also when will they be involved in the process. So this is where I guess I start my own personal opinion, because all of that was just very, but more work. based viewpoint. I think a passage that stood in my mind when I was reflecting about this, and I haven't been able to expound in work circles, I guess, is if you remember the story of Job, and he's been through the ringer. He has these close friends of his who have just pretty much piled stone after stone down the well where he's in the well, right, and like just tossed them down at him, and finally God, he comes back with this answer, or this question where he says, who is this that obscures my plans with words without knowledge? And I thought that this was powerful too, because I think Job is an example of a user, extreme example of a user who's been through the worst user experience ever possible, right? He's lost his family, he's lost all these things, and there's no system status or any reason for why these things are happening in his life. Like, there's nothing giving him like why, he's just left with the consequences. And so I think something beautiful about also this is that God, he's not vilifying Job. He's not saying, Job, your friends are all right. You've just been awful, and that's why you deserve all this. And I think that speaks to me too, and probably all of us, when we go through suffering or different challenges that we don't understand where the reason or rationale for it. I think it kind of comes back to also, even for device design, it comes back to we need to be a bit more compassionate and empathetic about realizing, rather than the thought process of saying, oh, those stupid users, why would they ever think to do that, versus, wait, what are we doing to make them do that? The other part is also, I think, where the image of Hagar, and she's in this very vulnerable position in the desert, and just there seems like there's no hope. They run out of water and everything, right? And yet she recognizes where she said, this is the God who sees. And I think that's the other perspective I'm taking away. It's like, what are we forgetting where God sees? Be it, in the case of reprocessing, a lot of those users, they don't have the highest education levels. They're not necessarily paid very well for their job. What are ways that we can see to make things more clear for them, versus to make it as complicated as possible and think that the technology will solve everything? And I think this was just a quick kind of run comparison and thought of, and it'd be great to hear more dialogue on this, but it made me reflect on where, design of man and design of God, for instance, about the identity part. So design of man, we're generally limited with scarcity as a mindset, versus where God, he's limitless with abundance. It's flourishing that he seeks, right, in the garden and everything. About identity also, and who and why, the purpose for doing things. And generally for design of man, there's pretty much usually an impure purpose for things. I mean, profit and all these other things that have to come through, versus where God, he really does come from pure love, and he wants to, again, see us flourish. About the process. And so for man's design generally involves blueprints and lots of teams and lots of others, whereas God, as other people have iterated in beautiful ways, he just speaks and therefore it is, right? So he says and therefore it is. That kind of also emphasizes the other part of the process. For our human design, it's a lot of iterative and generally always requires maintenance of some form, as you've kind of heard some examples of, versus where God's design, it starts with being at a perfect state, and with sin it got corrupted. For risk side, it's very easy for man's design to be subject to unexpected or unintended consequences of harm. And usually in risk management in med devices, they'll just say, we can only just account for a single fault failure. We don't count for the double fault. Yet I believe there's lots of examples, even in the environment elsewhere in God's design, where he focused on life-giving restoration, that you can have pretty much horribly treated parts of land and you see it back where it can come back to flourishing, and or at, lots of levels of fault tolerance. So and I think also, just stepping back, I think one of the beautiful stories, there's many others of healing in the scriptures, but this one comes to mind, where there's the Good Samaritan that's brought up. And I think the other takeaway is that he doesn't necessarily go and pick the highest technology factor in helping to bind this person. He is a person that he barely knows, which I think is similar to people working in designing products. You might not know that person who might end up using your product, but at the same time, he takes it at a very personal level, and he applies love where he binds his wounds, he pours in oil and wine, and cares for him in this way. And I think that was a really beautiful reminder for me also, the level that, where are we potentially blindsiding ourselves with, oh, this technology will fix everything, versus maybe, that balance with understanding the person and the user a bit better. Thanks for your time.
We Mass Media, media empowering community.